Okay, class, picking up where we left off at. What do you notice about the relationship between the number of elements in the set and the number of subsets? Do you notice a pattern with respect to the number of subsets? Now you have to look back at that chart that I originally gave you in the last video near the end. And this is the relationships here. We gotta note, it can be seen that when we increase the number of elements in a set by 1, the number of subsets double. If we look here, we have a number of elements, and if you notice, the subset doubles. As we add 1, we go here from 0 to 1, and then we end up doubling it. From 1 to 2, end up doubling that, and also from 2 to 3, we end up doubling here. Now, it says the number of subsets seem to be a power of 2. Now we come here, look at the number of subsets. Now if we look here, when it says that it's a power of 2, basically it's saying this here. The number of subsets is 2 to the power of the elements. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the second is 4, and 2 to the third is 8. So the number of elements is the exponents, and we would take 2 to the power of the elements, and that would give us the subsets. Now, it's shown more graphically here, the number of elements, like I showed you, 0, 1, 2, and 3. We would take 2 to the power of the number of the elements, and then that will give us our number of subsets. Now, it says from the above table we can see as we increase the number of elements in a set by 1, the number of subsets double. The number of subsets of a set with n elements is 2 to the n power. For a given set, we know that every subset except the set itself is a proper subset. Thus, the number of proper subsets of a set with n elements is 2 to the n minus 1. Now, the number of subsets. The number of subsets of a set with n elements is 2 to the n. The number of proper subsets. The number of proper subsets of a set with n elements is 2 to the n minus 1. Now, we scroll down. Go to our next example. It says, example, find the number of subsets and the number of proper subsets. So this is what we would do. First thing, we would count how many elements we have. We have 5 elements. Now what we need to do to find the amount of subsets, we would take 2 to the 5th power. Now remember, the number of elements, this answer here is actually our n. So this is the same as saying 2 to the n is equal to 2 to the 5th, which is equal to 32. Now that is our subsets. Now, in order for us to get the proper subset, this is what we need to do. We need to take 2 to the n minus 1, which would be 2 to the 5th minus 1. Now we know 2 to the 5th is 32, minus 1 is 31. So it'd be 31 proper subsets. Now we go down here to B. Now what we have here is a situation where I think that we should write this as in the roster method. I think that would make it a lot easier. So writing this in a roster method, we would add 9, 10, 11, 12, 13, 14, and 15. As remember, it's x is greater than or equal to 9, but x is also less than or equal to 15. So these are all the counting numbers, and we know this n means counting numbers. So now we count how many elements we have. We have 1, 2, 3, 4, 5, 6, 7 elements. So we know it's 7 elements, so we know this is our n, which is 7. So now, to find our subsets, we will go 2 to the n, which is equal to 2 to the 7, which is equal to 128. So it's 128 subsets. Now we want to find proper subsets. So we know we will go 2 to the n minus 1, which is 2 to the 7th minus 1, which will give us 128 minus 1, which is 127 proper subsets. Now we look here at C. We have Mary, John, Fred, and Sue. Now we know it's 4 elements in this subset, and we know this 4 is our n. So we have 2 to the n is equal to 2 to the 4th, which is 16. So it's 16 subsets. So now to get our proper subsets, we'll take 2 to the n minus 1, which is 2 to the 4th minus 1, which is 16 minus 1, which is 15. And it's 15 proper subsets. Okay, now we come to D. Now we have our natural numbers, and we have x is greater than or equal to 11 and x is less than or equal to 17. So let's write this in a roster method. We have 11, 12, 13, 14, 15, 16, 17. Now if we count how many elements we have here, we have 7 elements. So we know our n is 7. So our n is 7. So we will go 2 to the n is equal to 2 to the 7th power, which is 128 subsets. Then we'll have to get proper subsets 2 to the n minus 1 is equal to 2 to the 7th minus 1, 128 minus 1, which is 127 proper subsets. Now, we scroll down here. It says the number of subsets of infinite sets. In the previous section, we talked about the fact that the infinite set of natural numbers, which is the subset of 1, 2, 3, 4, 5, or the elements 1, 2, 3, 4, 5, and so on with those ellipses, is assigned the cardinal number. And as you see, we have this symbol here, which is alpha null, called a transfinite cardinal number. Equivalently, there are alpha null natural numbers. Since there are alpha null natural numbers, we can make the following definitions. There are alpha null natural numbers. It has 2 to the alpha null subsets. It has 2 to the alpha null minus 1 proper subsets. 2 to the alpha null is greater than alpha null. If we denote 2 to the alpha null by alpha null 1, then we have alpha 1 is greater than alpha null. Alpha null is the smallest transfinite cardinal number in the infinite hierarchy of different infinities. And this is it.